Welcome to The Explainer. So you're a data scientist, and you're ready to level up your skills, move into MLOps, and start building some seriously robust AI systems. If that's you, then you are in the perfect place. Today, we're going to nail down a skill that is absolutely foundational: experiment tracking.
All right, let me ask you a question, and be honest. Can you really, right now, reproduce that amazing model you were so pumped about last week? If you're hesitating or thinking, maybe, don't worry. You are definitely not alone. The whole process can feel, well, a little chaotic.
And that's the chaos I'm talking about. You know the feeling, right? A jungle of Jupyter notebooks, parameters you think you wrote down somewhere, and that one perfect model that, for some reason, you can never get to work again. As you move into pro-level MLOps, that just isn't going to cut it. So how do we fix this? How do we bring some order and sanity to the chaos? The answer is a professional discipline called experiment tracking. This is what separates the weekend projects from the production-grade stuff.
I want you to think of it just like a scientist's lab notebook. Seriously, every single trial, every variable, every outcome, it all gets written down. It's really just the systematic process of logging your code, your data, your environment, and your parameters for every single model you build.
And the payoff for doing this is just huge. For starters, you get reproducibility. That's the big one, the ability to recreate any result anytime. But it's more than that. It helps you find the best hyperparameters methodically, it keeps all your work neat and tidy, and it plays nice with all the ML frameworks you're already using. It's your professional foundation. Okay, so you're on board, you get it. But what tool do you actually use? Now, there are a bunch of great options out there, but we're going to focus on a fantastic one for anyone starting out or for anyone who just wants a super versatile open source solution: MLflow. Now, the thing that's so great about MLflow is that it's framework agnostic. And that's just a fancy way of saying it doesn't care what you use. TensorFlow, PyTorch, Skitlearn, XGBoost, you name it, MLflow works with it. It's powerful, flexible, and honestly, the perfect way to get started. And get this, getting started is ridiculously simple. It is literally 2 commands in your terminal. First, pip install MLO. Second, you type MLOU UI, and that launches the web interface. That is it. You're now ready to go. All right, theory's great, but let's see what this looks like in your actual code. We're going to walk through the key lines you need to add to get your very first experiment logged. Okay, first step in your Python script, you have to tell MLflow 2 things. First, where to save all this good stuff. That's the set_tracking_URI. Here, we're just telling it to create a local folder called MLruns. Second, you give your experiment a name, just to keep things organized. Okay, now this next line, this is where the magic really happens. This one single function, mlflow.autologging, is an absolute game changer. It automatically snoops on your training process and grabs all the important stuff, your metrics, your parameters, even the model file itself, without you having to write tons of extra code. It's amazing. And the last piece of the puzzle is this little with statement. You just wrap your existing model training code inside this MLflow start run block. Anything that happens inside this block is now officially one run that gets logged and tracked. You can even give each run its own unique name. Okay, so let's fast forward. You've done the work, you've tracked, a dozen different runs with different settings. Now what? What was the whole point? Well, the payoff is now you can easily compare all of them and confidently pick the winner. And MLflow gives you 2 awesome ways to do this. You can pop open that web UI we launched earlier for a really nice visual side-by-side comparison. It's perfect when you just want to explore and see what's going on. Or you can use the API to pull the results with Python, which is perfect for automating things like in a CI/CD pipeline. Because at the end of the day, it all boils down to this one simple goal. All of this tracking, all of this organization, it's all so you can make a clear, data-driven decision about which model works best. No more guessing, no more, I think this one was better. You'll know for sure. Okay, let's pull back for a second and look at the bigger picture. How does this one habit, this one practice, fit into the entire MLOps lifecycle? Well, it's not just some tool you use during development. It's actually the glue that holds your whole workflow together. So, in the development phase, it gives you that structure we've been talking about. Then, for CI/CD, those artifacts you logged, the model files, the metrics, they become the direct inputs for your automated deployment pipelines. And then, once your model's in production, those same training metrics become the baseline you use to check for model drift. See, it connects everything. So really, what we're building here is more than just an organized folder of models. We're creating a workflow that is transparent, auditable, and just plain efficient. This is the practice that truly speeds up your journey from a simple idea in a notebook to a real, live, production-ready model. So look, the tools are right there, they're simple, they're free, and they're ready for you to use right now. You officially have your digital lab notebook. So my only question for you is, what are you going to build first?